In today's lecture, we will explore a fundamental concept in array manipulation, the insertion of elements into an empty array. This topic is pivotal in understanding how we can dynamically populate an array, a skill that is essential in many programming scenarios. The content of this lecture covers the following topics. First, introduction to array insertion. Second, graphical representation of array insertion. Third, syntax for inserting an element into an empty array. Fourth, an example in the C programming language demonstrating the insertion process. And fifth, a project designed to enhance comprehension of the insertion concept. In our previous sessions, we have delved into the basic of array declaration and traversal, building a solid foundation for our current exploration. Today, we will take our understanding a step further by addressing the specific challenge of inserting elements into an initially empty array. Let's commence by defining the process of inserting one or more elements into an array. Insertion, in the context of arrays, involves adding a new value at a specified position within the array. It can also be described as assigning a value to a given index in the array. This operation can be performed with a single element or multiple elements, allowing for dynamic modification and expansion of the array. Let's utilize graphical representation to comprehend the concept. Through this graphical representation, we gain insight into the process of inserting element into an array. In figure 1, we depict an empty array with no existing elements, specifically of type integer. To illustrate the concept, we aim to insert two elements into the array. It's important to note that the array accommodates data value only of its declared type. As the array is declared as type int, it can only accept integer values. Now let's explore syntax for inserting an element into an array. The syntax for insertion is shown in the slide and it's simple, akin to assigning a value to a variable. First, we declare the data type of the array, accommodating any valid data type in the C programming language. Next, the array name, serving as its identifier, is assigned a memory address. Following this is the index, always a positive number, indicating the position where the value is to be placed. It's crucial to ensure that the index value does not exceed the capacity or size declared for the array. Using the assignment operator, we can then store a value from the right-hand side, ensuring it matches the same data type declared for the array. Let's look for an example to insert element in an empty array. Here is an example of inserting an element into an empty array in the C programming language. We begin by declaring an integer type array of size 5. Since the array is only declared and not initialized, it does not contain any values and is completely empty at the beginning. In the next 3 lines, we perform the insertion of data at different indices in the array. We insert 100 at index position 0, 500 at index 1 and 60 at index 4. We then execute the program and observe the result, which are displayed using 5 printf statements. As you can see in the output window, at index 0, 100 is present, at index 1, 500 is present, and at index 4, 60 is present, which are the values we inserted at the respective places. Now, index 2 has 88, which is a garbage value since we have not inserted anything at that position. Similarly, at index 3, 0 is present. To address the problem of garbage value, the array is initialized with zeros at the beginning of the program. Let's explore an application that involves inserting an element into an initially empty array. Write a C program to record the attendance of student for today's lecture. Use the indices to represent the roll numbers of the student. Increment the indices to match the exact roll numbers. The code for the previously mentioned problem is presented here. There is an empty array named attendance of size 5. Variable index and capacity hold the lower and the upper bounds for the array respectively. We initialized a while loop with the condition that it will run until the index is smaller than the capacity. Within this loop, we can use the syntax for inserting values at the array to fill the value at the given index position. With every pass, the value of index is incremented by 1 to move the pointer to the next index. In the following for loop, we print the content of the array. We have tabulated the data present in the array representing present for 1 and absent for 0. You can try running this code yourself to gain a better understanding of the concept.